welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Hyperbola Discovery Center. Our session for today will be focusing on paper 1 revision. And then on paper 1, the focus will mainly be on the following topics, that is algebra with your functions and graphs. And then now, before we can start with any topic, grade 12, let's go through the topics and the weightings of the content area for each topic that you will find on your paper 1. So the main topic is algebra, and then it is carrying 50 plus minus 3 on your paper 1, and then followed by functions and graph. And then on functions of graph and graphs, we are having 35 plus minus 3. They can be more by 3 or less by 3. And then followed by financial growth and decay. And then with finance, we are having a weighting of 15 marks plus minus 3. And then finally, we will be having the last topic, which is the differential calculus with integration. Remember, these two, they are having a relationship. That is why they are clustered together like that. But look at the weighting grade 12. They weigh 50 plus minus 3 marks on your paper 1. That means the main topics that are carrying more marks is algebra and differential calculus with the integration. That is the weightings for your paper 1 and the topics that you will find on your paper 1. And then now at the back of your question paper, you are having the information sheet, of which we normally call it a formula sheet. And then remember, on that formula sheet, we are having two categories of formulae, which is the paper 1 formulae followed by the paper 2. The main ones that are starting at the starting point of your information sheet, we are starting with the paper 1 formulae. And then grade 12, please ensure that you know how to classify those formulae at the back of your question paper. The first class there, we will be having the algebra, functions and graphs. That means for this particular formula, you will be applying them when you are looking at your algebra, when you are looking at your functions and graphs. And then the first formula there is the most common one, which is the quadratic formula. Remember, the quadratic formula, you use it anywhere in a quadratic equation where there's a need of factorizing. You can only use this if your equation is a quadratic. Remember, a quadratic equation, we are talking to an equation of ax squared plus bx plus c equals to a 0. That is the only equation in which you can apply a quadratic formula for factorization. You can't use this equation to factorize a cube, x to the power 3. We cannot use this particular formula, grade 12. And then now the formula states that x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. Now, the misconception on most mistakes that are done by learners in this particular equation, please double check your formula by looking at the back of your question paper, because most of the cases you forget that this division line, it includes everything from minus b there, not only for the root sign. And then secondly, you must ensure that you are having a plus minus. That means you are having two solutions there. You'll find that most learners, they only consider the plus one. They forget that we are actually having two solutions there. Another mistake, grade 12, is that most of the learners, they omit this exponent 2 there on b squared. Please ensure that it is a b squared. And then finally, now last common mistake, instead of having a minus 4 there, they sometimes write a positive 4 there. So you have this formula on your formula sheet. There's no need for you to write an incorrect formula. Go back to your information sheet and double check the formula before you can use it. All right. And then the next formula now on your formula sheet, it is an equation x equal to minus b over 2a. Also, this one is relying on your quadratic equation. As you can see that it needs the p-value of b and the value of a here from your quadratic equation. And then when do we use this formula now? When we are calculating the x turning point of a parabola or a quadratic function. And then now followed by the equation y is equal to the 4ac minus b squared over 4a. And then also this one, it only works with the quadratic equation, grade 12, ax squared. And then when do we use this formula now? When we are calculating the y turning point of a parabola graph or a quadratic function. And then lastly, now we are having the exponential one and the log. These two are having a relationship. Remember now, to get a log function, you need an exponential. To get exponential, you need a log function. They are the inverses to each other. And then now with the exponential one, we are having a formula on the formula sheet that is indicating the exponential equation a to the power x is equals to b. And then if we are changing this to a log, remember now, do you still remember grade 12 that if I'm having a to the power x equal to b, and then I want to bring this x down, maybe I am solving for an x, that means I need to introduce a log on the other side. That means this will be the log of b now. And then this a, since it's a base there, it will be the base on that particular log. This now enables the x on top there to come down there and then be a base. X is equal to log b equal to x is equal to log b base a. Hence you can see that a logarithmic equation. That means this is formed out of that exponential one. But there are restrictions around that one. Your a must be greater than 0. It must not be negative. It must not be equals to 0. So this a value here cannot be a negative value, and it cannot be equals to 0. And then a must not be equals to 1 again, and then your b must also be a positive value there. Okay, those are the conditions for your exponential and the log equation. And then after the algebra class functions and graphs, the next formulae are for finance, growth and decay. Please draw a line on your information sheet to know how far do you go around selection of formulas there. And then now with the finance, growth and decay, we are having the simple interest ones and the compound interest. What is the difference between the two? This one is a linear one. As you can see that n is linear there. And then with the compound one, it's an exponential one. As you can see that n is exponential there. That means now, for the simple interest, we are using these two linear equations stating that a is equal to p into 1 plus in and a equal to p 1 minus in. And then now for the compound one, we are using a is equal to p into 1 plus I to the power n. Can you see now it is now exponential? That means now this one is having a relationship with the exponential graph. And then the simple interest is having a relationship with the linear graph. This type of questions can be given in terms of graphs. You must know if you are given a straight line one, it is having a relationship with the simple interest. If it's an exponential graph, therefore, it is related to the compound interest. And then now, as you can see there, even if you are having a simple, there's a formula that is a plus one and the other one is a minus one. Also with compound, we have a plus and a minus. When do we use a plus and when do we use a minus formula? So now you must read carefully into your statement. There are keywords that we are looking for grade 12. If you are having a plus, that means we are checking the increase, the word increase, the word appreciate, and then the word growth. If your statement talks to these three, you must know that you must select a plus. But remember, firstly, you must identify whether is it a simple one or the compound one before you select in terms of plus or minus formula. I hope you are still together with that one. And then if it's a minus one, we are targeting the decrease. We are looking for depreciating value. We are also looking for a decay or a decrease in value. Decrease, decay, depreciation. Those are the keywords that are telling us that we must use a negative formula now, because the value will now be going down. Okay, increasing, we are adding, therefore we take a plus formula. We decrease, we are minusing, then we take a minus formula then. And then how do you differentiate now between the simple selection of simple and the compound? You must look for the keyword simple interest, or SI in abbreviation, or you must look for the linear base, or you must also look for the high purchase. The minute they say something is bought under high purchase, or the payment is done for a high purchase item, you must know that it falls under the simple interest. And then for the compound interest, we look for the keywords like reducing balance, we look for population, we look for the inflation. All those keywords are telling you that go for the compound interest, or we look for the word compound interest itself, or the abbreviation CI for the compound interest. Then it will assist you, those keywords will assist you greater in terms of selecting the correct formula. Finally, we are having an effective and the nominal rate equation. It's also on your formula sheet. It falls under the finance growth and decay. That means that I effective is for effective rate, and then this I is for nominal rate, and then the M here is for compounding. Whether it's compounded monthly, then that M will be 12, and then compounded quarterly, that M will be 4, and so forth. Compounded daily, 365 days, and so forth. And then the last two is for differential calculus and the integration. That is all about your paper 1 formulas. They end with integration. Okay, now with the differential calculus, we have only one formula that we use from your formula sheet. That is the f derivative of x is equal to the limit of f at x plus h, and then minus the f at x over h. That is for the first principle. That means when you start answering the differential calculus, the first question will be on first principle graders. And then what mistakes do we encounter around this one? Most learners, they forget to put that dash there. The minute that dash is not there for the derivative, that means it's a notation error. You're going to lose 1 mark for that one. And then some learners, instead of putting an equal sign there, they put it in between there after the limit there. So that is a notation error, grade 12. And then now some learners, they omit this limit. They only write the f at x plus h minus f at x. It's also a notation error, grade 12. Please always visit your formula sheet to ensure that you select your formula correctly or you copy it correctly. So, and then lastly, we are having an integration formula. The integration one, they are assisting you a lot in terms of the given integration problem. You look at the problem and try to relate it to the types of formulas that you are having. This will guide you directly to the correct answer, grade 12. Directly to the correct answer. This is assisting a lot in terms of answering the integration. You can't just answer any integral without checking it falls within which one out of the 6 that we are having there. So we are having the first one is for when you are having a number on an exponent. For example, we are having an x squared. That means we are following this rule. And then if you are having a constant number before you have your x to the power n, for example, when you have 2x to the power 2 there, then you apply the second one. This one is when maybe you are given only the x squared there. Can you see your coefficient is 1 there? Therefore, you apply this rule. And then for this one, it's when you are given now 1 over something, for maybe an integral of 1 over x. Can you see that? It must be 1 on top. Then it becomes a line there. And then this one, look at the top part there. The numerator is now a constant value. For example, when you are integrating something like 2 over x now, then you follow this rule. Can you see a difference, grade 12? And then now the last one, let's look at this one now, is when you are integrating a number to an exponent x. Can you see now x is exponential? X is on the exponents. That means you follow this one. And then lastly, the last one is when you have a coefficient of a being greater than 1 now. Remember this one is having coefficient 1 there. With the last rule there, it means you are looking at the integral when you are having a value there and then a, and then on the exponent again we are having something like 3x, something like that, K12. So you must know that you need to apply this rule. So that is why I'm saying to you, it is very important that you look at the integral given to you and relate it to your formula sheet. Your formula sheet will guide you which one to select to answer that particular question. All right, and then let's go straight to our activities. We are now looking at the first topic, which is algebra, of which is carrying most of our marks, grade 12, which is 50 plus minus 3. Please, let's give this topic an attention as far as possible. Now, the first question says that we are given the f at x, which is equal to x plus 3, and then we are also given the g at x, which is equal to x cubed minus 16x. And then they say solve for x with the conditions given below. And then 1.1, we are given that f at x is equal to 2. That means they say solve this, but using what? The f at x formula. What is f at x? F at x is x plus 3. We are going to substitute that for f at x because f at x is equals to x plus 3. Okay, and then now this will be equals to 2 because that was given as f at x equals to 2. Remember, you are solving for x, so then we will transpose this 3 to the right. It will be 2 minus 3. Then our answer will just be a negative 1. Okay, great terms. And then this is allocated 2 marks. The first mark will be for substituting the x plus 3. And then the second mark will be for your final solution with x is equal to minus 1. That is your 2 marks, great terms. And then 1.12, let's continue. With 1, do not mix them, grade 12. You must be careful. You are given 2 equations. You had to listen to your question. Which one must you select to solve that one? And then with 1.1.2, it is indicated that g at x is equal to 0. That means what is g at x now? G at x is x cubed minus 16x is the one that is equals to a 0 there. And then remember now, our work is to solve for x. Now, if you look at this, is x to the power 3. But fortunate enough, we are having what? A common factor. Our common factor of which is x. Can you see that you have x and x there? Then we are going to take that common x out as our common factor. So out of this x to the power 3, we are having x. We now take 1 out, then you'll be left with 2. Therefore, it will be x to the power 2 left in the bracket minus, out of 16x, we are dividing by x. That means it will be 16x divided by x. X will cancel x. So we are left with minus 16 there. That is equals to 0. We are not yet done, grade 12, because you need to solve for x. We must end up where we have x equal to and so forth. And then now if you look at the first one, x, we are okay with that one. But inside the bracket, we are now having difference of 2 squares. Remember, square numbers are 1 squared, 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, and so forth. So if we are having 16 here, that means we are actually having what? 4 squared. That is why we are saying it's a difference. Remember, difference is a minus. It's a difference of 2 squares, of which is an x squared and another 4 to the power squared. It's a difference of 2 squares. So now how do we factorize this? We end up having bracket of the same thing that will be x and 4. We are now sharing these 2 x's equally so, and the 2 4's 4, 4. And then the other bracket will be negative, the other one positive. Always when you factorize the difference of 2 squares, it must be a bracket of the same thing with different sign. Okay, and then now we can now conclude our x values here. The first x will be x equal to 0, and then for this bracket it will be or x equal to 4, or for the last bracket x will be equal to a minus 4. So basically that is what is expected of us. You can even substitute the values in g at x and check can they give you that 0 there. And then if it's a 0, that means those are the perfect correct solution. And then now 1.1.3, we are given f at x is equal to the x squared, and then they say correct to 1 decimal place. The minute grade 12 there is this message here, it is automatically telling you that this quadratic equation does not have factors, so you are forced to use a quadratic formula. Remember we talked to that on the formula sheet earlier on. So now we need to understand before, what is our starting point? We are given f at x is equal to x squared. F at x now. And then what is our f at x? F at x is x plus 3. So we are taking x plus 3, plug it in there. And then this is now equals to the x squared. Can you see now? We have an equation, but we need to transpose everything to one side. Then I'm deciding to take the left hand side to the right hand side because I am targeting the x squared that is already on the right hand side. Okay, so now I will be having a 0 on the left, and then this will be x squared. The minute I take positive x to this side, it will be a minus x. Take a positive 3 to this side, it will be a minus 3. Then we are now having a quadratic equation. Okay, remember the coefficient. If there's no number there, we know that there's a 1 there. There's a 1 there. That means now the a value here is 1. The b value will be minus 1. And the c value will be minus 3. Remember to take the whole thing there. The constant value there. Without an x is your c value. Coefficient of x squared will always be your a. Coefficient of x will be your b. And then the constant number will be your c value. Now we go into the formula sheet. We select the quadratic formula, which says that x is equal to minus b plus minus the square root of b squared minus 4ac all over, look at my division line, it starts from minus b over 2a. The next part is the substitution part. Now I am not simplifying anything. I am just removing an a, putting an a value, b value, and c, and so forth. So now we are having a negative here from the formula. There we are. And then now bracket for substituting the b value. So this b value comes with a negative. That means we'll be having another negative for b. Be careful, grade 12. It's the negative from the formula and the negative from the b value now. And then we have plus minus the square root. For the b value, we are having a minus 1 squared. Look at that, is exactly the same as that one. And then we are having the minus 4. What is the a value? A is 1. And the c value is minus 3. And then all over 2. What is the a value? A value is 1. And then grade 12, from this one, do not do the partial simplification. Please put everything into your Casio or Sharp calculator. It will give you the simple set form. Before you go final answer, give us the simple set form. And then what is the simple set form for this one? It will be 1 plus minus, I hope we are still together, the square root of 13 all over 2. Remember, it's a plus minus there. And then from this one, now you can now press your SD button to check the decimal form, bearing in mind that you are correcting to 1 decimal. Most of the cases, they will be saying 2 decimal, but in this case, it is specific that we need to correct to only 1 digit after a comma. Okay, so now the first value here, let's see, now we have x. As you press your SD button, it's giving you 2,3 and so on. So because we need only 1 digit, we'll stop at 3 there after a comma. And then or the next x value will be equal to the minus 1,3, only we stop there. And then now let's look at the mark allocation for this one. It is 4 marks. 1 mark it will be for the correct trinomial transposing, substitution, and every simplifying. The second mark will be for substitution into the correct formula. The third mark will be for the first x value, the fourth one for the second x value. So this question worth 4 marks, grade 12. And then with 1.1.2, the mark allocation, this problem worth 4 marks. The first one will be for factorizing by taking your common factor. The second one will be for difference of two squares factors. And then now the third one will be the solution of x equal to 0. And the fourth one for the plus minus 4, two solutions of positive 4 and negative 4. So this problem will worth 4 marks. The next question, 1.1.4. In this case now we are having an inequality. Look at the level of the paper, grade 12. We started with factorization, and then we went to quadratic formula, and then now we have an inequality question. Inequality question is where we are having greater than, greater and equal, less than, less and equal. That is not an equation, it's an inequality. Now here we have an inequality, 1.14. minus 3 minus x is greater and equal to x squared minus 5. With the inequality, the best way, grade 12, is to take everything to the left and be having a 0 on your right hand side in order to be able to see whether you are multiplying by a negative throughout, of which is going to affect your inequality. Remember, when you are multiplying with a negative or dividing with a negative, the inequality sign will change. If it is greater than, it will be less than. Okay, the negative multiplication or division is having an impact on your inequality sign. Right, I'm starting with the transposing part now, everything to the left. As I'm transposing, I am also rearranging in correct order of a x squared, b x, and c. Okay, starting with x squared followed by x and then the constant number. Let's see now, x squared to the left, this will be minus x squared. Correct, followed by x, correct sequence is that one, and then minus 5 to the left, it will be positive 5, and then 5 minus 3, it will be plus 2 with a greater and equal to 0. When we are transposing, we do not change the inequality, grade 12. The inequality sign will only change if you are multiplying by a negative throughout, or you are dividing by a negative throughout. But when you are transposing, we are not affecting that inequality. Okay, right. We have a challenge now. Our x squared is negative. So we are going to multiply throughout by a negative. With inequalities, ensure that your x squared is always positive, all right, before you can continue with your solution. So we multiply by negative throughout or divide by negative throughout. So now multiply by negative, everything is going to change its sign. The minus x squared will become positive x squared. The minus x will become positive x. The plus 2 will become minus 2. Remember, this is affecting your inequality sign. It is saying greater and equal. It will change to less and equals to 0. I hope we are still together, grade 12. And then now the trinomial is always talking to you in terms of factors. This trinomial is saying to us, look for factors of 2, right? When you subtract them, you must get a positive 1. We know that factors of 2 are only 1 times 2. In order for this, when you subtract, you get a positive 1. That means 2 must be positive and 1 negative. Happy now we have tested everything. We can now bring this down here. Remember, this is less than equal. Then it will be x minus 1 and the x plus 2. You can test also, grade 12, multiply them back. They must be able to reverse to its trinomial step here. Okay, now you can also use the quadratic formula. If you are not comfortable with the bracket type, you are more than welcome to use the quadratic formula. No penalty for that. And then because we are solving an inequality, we are going to criticize these values because we are now going to let them be equal to with an equal sign. Hence, Whereas here we are solving for an inequality. That is why we are criticizing the values. Critical values, for the first bracket, x will be equal to 1. We criticize in order to be able to use an equal sign. And then or x will be equal to a minus 2. Since we have the critical values now, we have different methods now. Other schools are using the number line, others are using the parabola type graph, and then others are using the table method. I will go for the number line one. Stick to what you know, grade 12, what you are more familiar with, and then comfortable, the one that is giving you correct answers, all right? And then now when you display now your critical values, we always start with the smaller one. Remember, minus 2 is smaller than positive 1. So it will be minus 2 followed by 1. Now after putting the critical values, you look at the inequality sign. We don't consider that one. We consider the one that is being now affected by a multiplication of a negative. So this is less and equal to. Now if it is less with an equal sign, the values are included, then we are going to indicate that with a closed dot or shaded dot, because the values are included. There's an equal sign. Okay, if there was no equal, we will make an open dot to exclude those values. Okay, we do not shade if there is no equal sign on the inequality. And then now, since this is less than, less, we are coming closer to each other, we go this way, less. Okay, we go less. If it is greater, we will go that way. Then we are shading away because we are becoming greater. But in this case, because we are less, we are coming closer like that. Okay, so in this case, our solution will be going closer like that, this way, and then they meet there. And then since the solution is in between, that means your x will also be in between for this case. Between what? Minus 2 and positive 1, grade 12. Okay, that is the inequality case. And then let's say now this was a greater than, maybe this critical values x minus 1 and the x plus 2, the inequality sign was now greater than 0. Just to check what is the difference. You'll still have the same critical values, of which is minus 2 and 1. But now remember, because there is no equal sign here on the inequality sign, you'll be having open dot, because the values minus 2 and 1 is not part of your solution, but is everything that is greater than that. And then since it is greater, open here, and you see that is open towards your x-axis. Also between there will be an opening, so the solution will go this way, greater than, or they can follow. Remember, this is your number line with arrows following that direction. This arrow is exactly that one. This will follow that direction. And then now can you see the space in between here? That is an or in between. Okay, for greater than, open, there's an or there. And then that means in this case we'll be having two solutions of x now. So the first one will be an arrow less than minus 2. This one is greater from that one. It's an inequality sign there, which is greater than 1. I hope those skills will assist you, grade 12, to be able to differentiate the two notations. The next question, 1.2, we are solving for x and y simultaneously if 2 to the power y minus 16 to the power x is equals to 0, and then y is equal to x squared plus 4x minus 4. And then this is worth 6 marks, grade 12. And then we are used to having a linear equation with the quadratic one. But now, in this case, we are given an exponential one with the quadratic. If you are given an exponential, you need to come up with the linear out of that exponential equation. So your starting point will be, you will be targeting the exponential equation so that we can come up with the equation that we are familiar after simplifying that exponential equation, applying your exponential rules. Okay, now we take the exponential equation as our starting point. We are having 2 to the power y minus 16 to the power x equal to 0. And then since we can see now this is an equation, we are going to transpose the 16 to the right. This will be 2 to the power y. And then this 16 will be positive 16 to the power x when you transpose it to the right. Okay? And then from here now, we are going, remember the rules of exponents. When you are dealing with equation, you must have the same base. One term on the left, one on the right, and then they must have the same basis so that you can equalize the exponents. Okay? So now we are going to ensure that this 16 is written in its lowest base. Remember, we are using the prime basis when we are working with exponents, grade 12. So now 2 is a prime, it is already at a prime base. And then this 16, we are going to write it with a prime base. So the prime base for 16 is 2, then it will be 2. How much? 2 to the power what? To get the 16? That will be 2 to the power 4. And then remember there's an x there, it will be 4 times x, which is 4x. Or you can start maybe by putting a bracket there to show that 16 is 2 to the power 4. And then the next step, you can have your 2 to the power y, which is 2 to the power 4x. Happy grade 12, you now have a same base on the left and on the right, and then it's 1, 1. If that is the case, you can equalize the exponent. Therefore, y is equals to 4x. Can you see now? You have derived a linear equation that you are familiar with. So now, with this y equal to 4x in this next equation here, wherever we are having a y, we are going to put a 4x. That means for this y now, we are going to substitute a 4x. Let's do so, grade 12. So for y, we are having 4x on the left in equation 2. And then right hand side, we have x squared plus 4x minus 4. Alright? Remember, we need to have one side having a 0, transposing everything to the other side. Since we are directed now, x squared is on the right. To make our life easier, we are going to take 4x to the right hand side, and then we will be left with the 0 on the left hand side. Then right hand side, we have x squared. This 4x, when you transpose it to this side, it will be minus 4x. And then the minus 4x plus 4x will give us a 0. And then now we are left with only minus 4 there. Can you see what is happening here, grade 12 again? We are having what? Difference of 2 squares, because 4 is a square number. Remember, it's a 2 squared, which is 4. And then now this 4, we'll write it as 2 to the power 2. Okay? So that it can give us 2 brackets of difference of 2 squares. Then now, if it's different of 2 squares, we are having x and x here. We share it equally. X. We have 2 and 2, 2 2s, and then we put 2 there. And then now remember, is same bracket with different sign. Then this one will be minus, that one positive. Remember, this is equals to a 0. And therefore, our x will be equal to 2, or the x will be equal to negative 2. But because it is simultaneous equation, we are solving for both x and y simultaneously. Up to this stage, we have only solved for x. We also need to solve for y. We can take these x values and substitute in this equation that is already saying y is equals to, because we are looking for the y value. Now we are going to substitute the first x value, of which is x equal to 2, into this y equation. Then it will be y equal to 4 into 2. Then this is giving us 4 times 2, which is an 8. Same equation, we are now substituting an x with a minus 2. In the same equation, y is equals to 4x. Then for x, we are substituting minus 2. Then this will be minus 8. Therefore, grade 12, this will be your y values for those particular simultaneous equations. Okay, I hope you'll be able now to answer this one. Remember, if it is in exponential, there's your linear equation hidden somewhere in that exponential equation. deal with that one, simplify with the knowledge that you have, then you will eventually get what you need. All right, still on algebra, literal equations. Literal equations are those equations with letters. In most cases, they will be relating to your trade subject, electricity or mechanical or civil technology and so forth. They will be taking equation, or it can also be related to your technical science. They will take equations from those trades or your technical and bring it to mathematics now. And then in maths, we are solving that as literal equations. Okay. And then now this is the type that is given to us in 1.3. They say kinetic energy is the energy that an object has due to motion. And then now for kinetic energy, we are given the equation Ke is equal to half mv squared. And then what does m stands for? The m is for the mass, and then this mass is measured in kilograms. And then the v there is for the velocity, and then this velocity is measured in meters per second. And then we are given Ke, and then the Ke is for the kinetic energy, and then this kinetic energy is measured in joules. And then now the first question, now let's look at the question. Now we now understand the meaning of everything in the given statement, and then we can now attack our problems now. And then the 1.3.1, it says that write out the formula with V as a subject of the formula. That will be the case grade 12 in most of your papers. If you look at this type, they will be asking you to make one of the letters to be the subject of the formula. We are working mostly with letters here, okay? Now, we want to make V out of this formula that is given to us, which is Ke is equal to kinetic energy is equal to half mv squared. Remember, when there's a square somewhere, you'll end up with the square root sign, all right? If there's a square somewhere, you'll end up with the square root sign, okay? Especially on the letter that you are looking for. That square, can you see, is affecting v for velocity. Therefore, you'll end up with something with the square root. So that means you need to get rid of this part here, the half m. Okay, it's more than well. You are more than welcome, grade 12, to divide by half m both sides. It's okay with us. Then you'll be left with v squared on the right hand side, and then you'll have your Ke on the left hand side all over half m. And then now, if remember, the right hand side loses an exponent 2, this one will gain the square root. It was supposed to be plus minus the square root sign, but in this case, because we are looking at the velocity, we'll consider that velocity to be the positive one. So we are only taking the positive one here, okay? We are only considering the positive one. And then now, alternatively now, if you don't do it like that, you can take that Ke, let's start again from scratch. Ke is equal to half mv squared. Remember, our target is that v there. So one learner can see that I can multiply by 2 both sides in order to get rid of a half. So your target will be removing a half. So you multiply 2 out by a 2. So if we multiply by 2 here, and also multiply by 2, these 2 will cancel that 2 from the half denominator there. So you'll be left with mv squared on the right hand side. On the left hand side, we have 2 kinetic energy there. Right, we have a challenge now. We have to remove an m for the mass. So we are going to divide both sides by m. Then the m will cancel m. We are left with v squared. Then on the left hand side, we have 2 Ke, kinetic energy over mass. And then now the v velocity will lose an exponent 2. Then the left hand side will gain the square root. That means now this will lose this 2. And then on the left hand side will gain the square root. That will be 2 Ke, kinetic energy over mass. Okay, that is an alternative way of solving this. And this problem is 3 marks. So the first mark will be for dividing both sides. If you are using the first method, dividing both sides by half m. and then bringing in the square root sign. For having that v squared equal to something, you have a mark for that, and then the last mark will be showing that it will have a square root. First mark is for dividing, the second mark will be for having v squared, the third mark will be having v equal to the square root of whatever. That is your third mark. Either you use the first or the second method, it's fine with us. And then let's continue now. Grade 12, we are at 1.3.2. And then with 1.3.2, they say determine the velocity of a 55 kg woman. We are given 55 kg, that is the mass of that particular woman, and then who is running, and her kinetic energy, okay, is 411. This is KE, 675 joules. And then they say now determine the velocity. We are looking for V there. Determine the velocity, right? My advice is that to be safe, stick to the initial formula. Because if you can use yours that is saying V is equal to something, and it happens that you simplify it wrongly, it will affect your answer, okay? But if you go to original KE equal to half mv squared, and then we now substitute whatever we have. We have kinetic energy is 411,675 equal to half. We are given a mass of 55, and then we are having that v squared. We know that we are looking for this v here, and then now you now divide both sides by half 55, and also by half 55 this side into your calculator, grade 12. And then now if you divide both sides by that particular number, you'll end up, you can leave it in a fraction form, it's fine, or you can put it into your calculator, and then that will give you something like 14.97. okay? And then now remember, if you get rid of that 2 on the side, this will gain the square root of 14.97. And then your v velocity will be equal to 3.9. Remember, this is measured in meters per second. We want to also see those units on your answer there. Right. Then this learner is confident enough, knowing that the first solution in 1.3.1 is correct. That means you may also use that formula that you have concluded in 1.1.3 that states that V is equal to the square root of 2 KE all over M, and then you can start substituting in that one. That is 2. Our kinetic energy is equal to 411,675 joules, and then don't stress about the units now, as long as you can indicate the final ones on the final answer, okay? And the mass, we are having 55. And then the velocity, everything into your calculator, it will go straight to 3.9. Then you add in your unit, which is meters per second. So that is the velocity of that woman who is running. Still on algebra, can you see grade 12 how far algebra goes? We have a subtopic again under algebra, which is nature of roots. And then with the nature of roots, remember this nature of roots is having a relationship with the quadratic equation. Remember, our quadratic equation is x equal to minus b plus minus the square root of b squared minus 4ac over 2a. And then now if we talk nature of roots, remember we are talking the discriminant is equal to b squared minus 4ac. That is the nature of root. We are using the discriminant. Can you see where does that discriminant come from? From your quadratic formula just below your square root sign there. That means your discriminant in nature of roots, it is having a relationship now with your quadratic formula. The minute it has relationship with quadratic formula, that means it is having a relationship with the quadratic equations, because it's quadratic equations quadratic function, quadratic formula, then the nature of roots. All of the four I've mentioned, they have a relationship, grade 12. Okay, and then now with the 2.1, let's see now what is expected of us. In this case, they say without solving the equation, determine the nature of roots of this 3x squared minus 5x plus 1. What do they mean when they say without solving the equation? They mean do not solve for x, like taking this in quadratic and factorizing. No, that is not what we are looking for. So that is why we have this restriction that is saying without solving the equation, solving for x. Okay, but when we determine the nature of roots, now we use the discriminant. So we are going to start with the discriminant now. Discriminant is equal to b squared minus 4ac. Can you see you need the value of b, the value of a, value of c. Remember, coefficient of x is the value of a, coefficient of x squared is a, of x is b, the constant value is for c. And then we can now substitute into the discriminant equation, and then b is minus 5 squared minus 4, the a is 3. We are busy substituting. The c value is 1. Do not partially simplify, grade 12. Put everything into your calculator and then straight to the answer. Then this gives us positive x. That means now it shows that your discriminant is positive, is greater than 0, positive, right? From your answer there. And then after checking whether it is positive or negative, you check that positive value. If it is positive, is it a perfect square or not? Remember, when you talk perfect, it's 1 squared, 1, 2 squared, 4, 3 squared, 9, 16, 25, 36, 49, 64, 81, 100, and so forth. But if you are having 13, can you hear that? We cannot have a square number that is 13. And therefore, it is not a perfect square. Not perfect square. So if that is the case, our roots will be, the nature of roots will be real, yes. Irrational because it's not perfect. If it was 25, positive 25, remember it's 5 squared, therefore it will be perfect square, the roots will be rational. But in this case, because it's a positive number which is not a perfect square, the roots will be irrational. And then unequal. Okay, remember we have equal roots if only our discriminant is equal to 0. Now when you calculate here, you find the value of discriminant in 0. Only then that you will be having equal roots. But for the rest of the roots, they are unequal. Now, mark allocation for this one. 1 mark will be for substitution into the discriminant formula. And then secondly, for the correct roots there. You want to see real, irrational, and equal. All of the three in order to get the second mark. Right. And then now with the 2.2, they say determine the values of k for which the equation, here we have our equation now. Can you see it's a quadratic? How do we know? Because exponent is 2. It's an x squared plus k plus 2x plus 3k equals to 2. We cannot work with the equation when there are numbers on the left and right hand side. We need to transpose everything to one side. So we are going to take a 2 to the left hand side. Okay, and rearrange in order if it is not in order. Okay, order of ax squared plus bx plus c. So start with the x squared. We have x squared, 1x squared, and then followed by the x. The x is having coefficient k plus 2. That is for x. And then for the constant value are all values without an x. We are having a 3k minus 2 equals to 0. We have transposed this 2 to the left now. This becomes a minus 2. Right. And then let's identify now the a value, the b value, the c value. Because when we are talking nature of roots, we are always talking to that because of the discriminant equation there. It's having a, b, c. Can you see that? And then now remember, the a value will always be the coefficient of x squared. That means our a in this case is 1. The b value is the coefficient of x, which is k plus 2. We are taking that bracket. And then for the c value is everything without an x, that is 3k minus 2. That will be our constant value for this one. And then now let's read the question again. It says, determine the values of k for which the equation, that is the quadratic equation given to us, has two distinct real roots. That means distinct means what? Different real roots. Okay? They must be different. Let's see now. Right. Let's see grade 12. They say it must be two real roots. Okay? And then now, in order to be distinct root, that means the discriminant must be greater and equal to 0. Okay? Greater and equals to 0. Remember now, if the discriminant is greater than 0, that is for real roots. And we have real roots when we have greater than 0, and then when we have equal roots. Okay, that is the case we are talking today. Okay, and then now let's continue. All right, grade 12. We cannot include the equal sign. Let me rephrase this. Let's go to our nature of roots condition now. If the discriminant is greater than 0, that means positive and perfect square. That means the value that you have for your discriminant now is now a perfect square. The roots will be real, rational, but unequal. Okay? Discriminant greater than 0 and then not perfect. That means it's real, irrational, unequal. And then when the discriminant is equals to 0 now, and then that means it will be real, rational, equal. This will be the only roots that have equal because it's equal to 0. And this means now, if you calculate your x values, you'll be having same x values. For an example, when we are factorizing the x squared plus 4x plus 4, if you factorize this or you simplify that quadratic equation, you'll be having x plus 2 as your factors and another x plus 2. Can you see you have same factors? So the x value will be the same x value, which is x equal to minus 2, giving you the same thing. That is the condition of equal to 0. But because here they say the two roots must be distinct, they must be different. So that is why we cannot put an equal sign there. Okay? Now we are taking our discriminant being greater than 0. What is the discriminant? B squared minus 4ac is greater than 0. Substitute the b value, k plus 2 squared minus 4a value 1, c value 3k minus 2 greater than 0. Remember, we are solving for k. And then now remove the bracket. You square the first term, that is k squared. Multiply the first by second by 2, that is 4k. Square the last term, that is 4. 2 squared. And then this 2 will give us a minus 4 here. Then we are multiplying, distributing this minus 4 in. That will be minus 4 times 3k. That is minus 4, 8, 12k. And then minus 4 times minus 2, that will be positive 8. Remember, this is still greater than 0. Then we target like terms, that will be k squared. 4k minus 12k, that is minus 8k. And then the 4 plus 8, checking like terms, that will be a 12 plus 12. And then greater and equal to 0. So this trinomial is saying to us, look for factors of 12. When you add them, you get a 8. Okay, remember factors of 12 can be 12 and 1. Can you add and get a 8? No. It can be 2 and 6. Can you add and get a 8? Yes, 6 plus 2 is 8. So we go for that one. Remember, there are other factors. 4 times 3 is also factors of 12. But now, because when you add 4 and 3 gives you 7, they cannot be factors of this. You listen to your trinomial. It says factors of 12. When you add them, they must give you an 8. And they must both be negative in order to get a minus 8. So remember now, the one that you add to get an 8 is to 2 and 6. So now we'll be having k minus 2 and k minus 6 greater than 0, because we need a minus 8 as a middle term. Okay, so can you see grade 12? We are solving an inequality again here, because now this is having an inequality sign. So now we look for the critical values. So we are criticizing k equal to 2, or the k will be equal to 6 there. So we go on our number line. We are having smaller number 2, the bigger one is 6, and then no equal sign on the inequality. It will be an open dot excluding the 2 and 6 in our solution. And then this is greater than, we are shading out, greater than, we go out. That means we will be going into this direction now. Okay, right? If there's a space in between, remember your solution will be separated with an or. So the first x value, check the arrow. It is less, it will be less also there, less than 2. Or x is, look at the arrow is going to the positive infinity. This will be also greater than the value there, which is 6. So that is the solution for that particular problem. Okay, and then the allocation of marks, no, this is the typing error. This is 5 marks. There's no way you can do such a huge job and only get a 2 marks. So the allocation is 5 marks there, and the first mark will be for substituting into the correct. Okay, first mark is for bringing 2 to the left, writing in correct order. Second mark, substituting into the correct discriminant equation. The third mark for the correct quadratic equation. And then the fourth mark will be for the factors. And then the last one will be for your final solution. So that is the 5 marks for that particular question, grade 12. Okay. Okay. Can we now go to algebra, logs, exponents, and set? Okay, grade 12, let's see how far did you go with this one. We are now looking at the logs, exponents, and sets. Remember, these also fall under the algebra. Remember our WhatsApp number, okay? You can send any question, any clarity seeking question to 079 454 9535, grade 12. Let me repeat the number again for you. That is 079 454 9535. You are more than welcome to send any clarity seeking questions to that particular number, or anything that you want to share with us which is technically orientated though. Okay, now let's look at the question there. 3.1, they say simplify the following without the use of calculator. Without using a calculator, that means you use all your application of logs, exponents, and sets without using your calculator, grade 12, right? And then now with the 3.1.1, we are given 3 log 20 minus log 4 minus log 2. And then if we simplify this, we must write it as a single log, okay? And then now if you look at these other logs, this is coefficient 1 here, 1 there. The only challenge is that one that is having a 3. So we are going to take this 3 back to exponential there. Then it will be the log of 20 to the power 3. Remember, minus log 4 minus log 2. And then we can now apply our logs rules. This will be log, single log. Now bracket. On top we are having 20 to the power 3. Or you can write it as 8,000, it's fine, okay? And then if it's minus, remember you have to divide now. The minute there's a minus, the rules say take it to the denominator, right? Or divide by that. That will be 4. And then minus, again, that means it will join this one on the denominator because it's the minus. Okay, so that is what you'll be having, grade 12. And then this is equals to what? The log of bracket 8,000 over the log of 8 there. So this will give us the log of 8 into that one once, then it's the log of 1,000. And then the log of 1,000 is the same as 3 log 10 because 1,000 is 10 to the power 3. So it's the same as 3 log 10. And remember, log, if it is not having a base there, there's a base which is base 10. So the log of 10 base 10 will give us a 1 according to our rules. Then it will be 3 into 1. Then the answer is equals to a positive 3. Okay, and then this is worth 4 marks. The first mark will be for writing, taking this 20 to the power 3, for bringing in the exponent back to that one. That is your first mark. The second mark is for writing this as 8,000 over 8. And then the third mark will be for the answer, which is equals to 3. Or alternative, the last mark, 1 for 20 to the power 3 second for the fraction form. The third one will be for 3 log 10 base 10, or where you have 3 into 1 for log 10 base 10. And the last one will be for the answer. Therefore, this is your 4 marks. Now, alternatively, one learner may see that, oh, if I'm having 3 log 20, I can write this 20 as 2 times 10. It's the same 20. And then minus, for log 4, simplify this to 2 log 2, because 4 is 2 to the power 2. Then it's 2 log 2, and then minus that last one, which is log 2 from this one. The learner is trying to create same log 2 throughout, okay? And then now we have 3. Remember, these 2, they share the same 3 log there. So that means this will be equal to 3 log 2. Since we are multiplying, it will be plus according to our rules, but remember it's a 3 log, ne? It's a 3 log 10. Remember, it will be base 10 there if there's no base. And then minus 2 log 2 minus log 2. That is our expression, okay? And then now we have 3 log 2 minus 2 log 2 minus log 2. You have 2 log 2s. How many? 3 of them. Out of the 3 log 2, you take out 2, minus 2 log 2s, and then minus the last one remaining. Can you see now they are cancelling each other? We have 0 there. Okay, and then now we are left with 3 log this one, this part here, 3 log 10 base 10. So the 10 base 10 will give us a 1. Log 10 base 10 will give us a 1. So your answer will just be a 3, which is the same as that one. So with the allocation for this one, the first one is for giving us this one in a product form. And then the second mark is for this step where you are simplifying it to the simplest, log 2. And then the third mark with for substituting your log 10 base 10 with a 1. And then the last mark will be for your answer there. So this log problem is worth 4 marks. Right. And then 3.1.2. And then if you look at that, you might say it's a complex number problem, but it also have the application of exponents there, since we are having exponent 8, exponent 7, and so forth. So there is some application of exponents. And then as you can see that you are having I being common throughout there. So we are going to target the common factor method now. On the numerators, you can see that the smallest exponent is exponent 6. That will be our common factor. So on top, we'll be having the I to the power 6 as our common factor. And then from 2I to the power 8, when you take out the I to the power 6, you'll be left with I to the power 2. Because when you multiply the same base, you add exponents. Remember, 6 plus 2 is 8. That is why we say when you take out the 6, we will be left with the 2. And then we have minus 3. And then we have I to the power 7. We have taken out 6. Then we are left with 1I. And then from that one of 4, we have taken I to the power 6. Therefore, only 1 left. Then it will be 4 times 1, still a 4. Okay. And then on the denominator, still taking I to the power 6 out of 9, will be left with 3 now. That will be 5I to the power 3. I hope we are still together, great child. And then the I to the power 6 will cancel the I to the power 6 on the denominator. Can you see now? We are now bringing in the complex numbers. Remember, when we have I to the power 2, in complex it is a minus 1. So that means this one, I to the power 2 here, will give us a minus 1. And then we have minus 3I plus a 4. And then on the denominator now we have, remember this 5I to the power 3 is the same as 5I squared with another I, so that they can be 3. So we are going to target this one now and put a negative 1 there because it's now complex. Ne? So we are having 5 into minus 1 for I squared, and then only 1I will be remaining, I to the power 1. And then now we continue. We have 4 minus 1, which is 3, minus 3I, all over. On the denominator, we have minus 5I. And then we are going to separate this now into the A and B part in a rectangular form. And then this one will be what now? The minus minus 3 over 5I, and the plus what? And the plus 3 over 5. Remember, an I will cancel I on these two, right? I will cancel an I. Then we are only left with 3 over 5, which is positive. Okay. Oh, we have left a 2 somewhere. Grade 12. Let's see back. We have I squared. Let's go back a little bit. We have I squared being common there. For this I squared, here, I to the power 6, I to the power 6, we are left with I squared. There's a 2 there. Can you see? We have lost that 2 somewhere, somehow here. Then this is a 2 there. And then 2 times minus 1 will be minus 2. And the 4 minus 2 will be a 2 there. So, okay, this is 2, and then this is minus 2 over 5. Sorry for that. Okay, that is your final answer there. Right, thank you for that one, grade 12. Thank you very much on that one. Okay, the 2 slips our mind, our eyes, and then now therefore we have brought it back so that our problem will be 100% correct. Right, let's look at the allocation of marks now. The first mark will be for the method of taking out a common factor. The second one will be for application of the complex number where you have I squared, we have now substituted with the negative. And the third mark for simplifying with that denominator 5i minus 5i. The fourth will be for the first value and the second one. Okay, if you want to rearrange this in a correct form, remember you must start with that one and then followed by 2 over 5i. That is the rectangular notation. 3.1.3, we are having a set now. The first one was a log, this one was exponents together with your complex numbers. 3.1.3, you are having your set application. And then remember, we are still simplifying. Okay, when you simplify a set, grade 12, your calculator will assist you in this case. Even though you use the calculator, we won't be able to see that, because if it says square root 7, it will give you 5 square root of 3. So if you want to be smart, you can bring back that 5. Remember, 5 out of the square root now. That means initially it was 25. So we're taking out the square root of 25 to be 5. So you bring it back in. If your calculator says 5 square root 3, when I write it as 25 times 3. Okay, minus, check with your calculator what is square root 27. It will say square root 27 is 3 square root 3. So we take this 3 in again, it will go back to 9 because 3 is the square root of 9 times 3 all over. You look at 48, it will say 4 square root 3 for 48. So that means initially it was 16 times 3 there. Okay, that means basically what you do here, you look for 2 numbers. When you multiply them, they give you 75 for square root 75. 2 numbers, when you multiply, they give you 75. One of the number must have a square root. Okay, but have you seen that? We can use a calculator, it will guide us somehow, it will assist somehow. Okay, and then this 25 we know now is 5 square root 3 minus the 3 square root 3 divided by the 4 square root 3. So first method, you can subtract because you have square root 3, 5 of them, and then minusing square root 3, 3 of them. So it's 5 square root 3 minus 3 square root 3. Therefore, this will give us how much? The 2 square root 3. On top, denominator, you still have your 4 square root 3. Then square root 3 will cancel square root 3. Your answer will just be 2 over 4. What is 2 over 4? Is your half. Okay? Or alternatively, from this step here, one learner may see that on top we are having the common square root 3 and decide to take out that square root 3 as a common factor from here and there. And then after taking out the common square root 3, the learner will be left with 5 minus 3. And then below we have 4 square root 3 there. And then this one will give us now 5 minus 3 is a 2. Can you see we still end up with 2 square root 3 over 4 square root 3. Cancel, cancel, it is still 2 over 4, which is still your half there. Okay. And then the mark allocation for this one, the first one will be for writing this in a simple set form. That means either at that step or at that point where we are multiplying the 2. The second mark will go for 2 over 4 with the square root of 3. 2 square root 3 over 4 square root 3, that part there. And then the last one will be for your answer half. Same applies here. First mark for the simple set, second mark for the 2 over 4 square roots, and then the last one for the half. Same application of marks for both methods. And then now complex numbers. Still on algebra grade 12. The Argand diagram shows points. So we are given point Z1, which is minus 4 and 2 in quadrant 2. Quadrant 4, we are given Z2, which is 2 and minus 3. And then they say determine the sum of Z1 and Z2. So we need the total sum now, okay? The Z total for this one, it will be Z1 plus Z2. So remember now, the equation for this one, in order to end up with that minus 4 and 2 as the coordinates there, this was from the equation of Z1, which was minus 4 plus 2i. Okay, and then this one was from the equation of Z2, which was 2 minus 3i. So if they say add the two, they say bring back their equations before you were plotting the Argand diagram. And then now that means our Z1 now will be minus 4 plus 2i plus the Z2, which is 2 minus 3i. And then let's add now. Remember, you start with the number and then you now come up with the imaginary number there. And then that will be minus 4 plus 2, which is equal to minus 2. And the 2i minus 3i will be minus I there. So that is the Z total there. Z total, the sum of that will give us the minus 2 minus I in the correct notation, grade 12. And then now the mark will be for the answer only for getting the minus 2 and the minus I. That is your 2 marks. Okay, because some learners, they can just identify that by looking that minus 4 plus 2 is a minus 2 and they end up with that minus 2. And then they know that this 2 must be a 2i. So it's 2i minus 3i, which is minus I. So other learners may just look at the coordinate and conclude the answer. Hence, the marks are only allocated for the final answer. And then 3.22. Write down the conjugate of the sum determined in question 3.2.1. That means now we are looking at the conjugate of that Z total. So it's the conjugate with the notation of a line on top to show that you are looking at the conjugate. Remember, if it's a conjugate, you only change the sign on I, on the imaginary part, then it will be minus 2 plus I. That is the conjugate equation. Then it's only 1 mark for that. And then they say draw both sum and the conjugate on the same Argand diagram. Remember, our Argand diagram is our Cartesian plane that we use in functions. But in this case now, because we are talking complex numbers, the y-axis will be the imaginary numbers. Okay? And then now the x line, it will be the real numbers now, because we are talking the complex numbers. And then now we want to draw the sum. The original one is minus 2. That means is on the side where the real values are negative, is this side, and then this side they are positive, imaginary, positive this side, and then negative this side. So we have minus 2. Remember, this is the real value, this is real, and then this is imaginary. Okay, so what is real value? It's a minus 2 coordinating with minus 1 on imaginary. Okay, minus 2 coordinating with minus 1. So that will be minus 2 coordinating with minus 1. We have a point there. Then it starts from 0, 0 there, it goes there. And then the coordinates will be minus 2, minus 1 for that one. That is for the Z total. Correct? And then now we want to draw the conjugate. Conjugate is minus 2 with the 1 now. Then it's minus 2 with the positive 1 there. Minus 2 with the positive 1. The point will be there from 0, 0 to that point. And then this one will be ZT total, but it's a conjugate. Therefore, the coordinate will be minus 2 and 1 for that one. We take the coefficient there, grade 12, as our imaginary number there. Okay, that is how you draw that one. So it will be 1 mark for each graph there, which were 2 marks there. And then moving on, we look at our functions and graph now. With functions and graphs, remember you have straight line, you have parabola, you have exponential, we have hyperbola. You also have a circle, semicircle, positive and negative semicircles there. So you have your circle as be part of your graph scripture. Now let's look at number 4. The sketch represents the function defined by f at x minus x squared plus 7x. The minute we see a 2 there, we know it's an the parabola graph. But this parabola is a concave down because it's a negative parabola there. Can you see the -1? That means the f function will be the one that is facing downwards because it's a concave down. It's a negative graph. Therefore, this equation of f is for this particular graph here. And then the second one is g at x is equal to 2 into x minus 2 squared minus 3. Since it is a positive, a value there is concave up. That means g is that one. Okay, and then h at x is mx plus c. Can you see the straight line? That means the straight line is the h graph there. And then the y-intercept of g is 0 and 5. The y-intercept is 0 and 5. That means at e here we are having 0 and 5. And then c and d are the turning point. Can you see that? We are having d there. We are having c there. They serve as our turning points of f and g respectively. The point E is the point of intersection of g and h. There at 0 and 5. It's where our straight line and our positive parabola is intersecting. They say determine the length of EF. Let's look at EF. Oh, we are moving from that point to that one. That is the distance between the 2 points. And then if we look at EF now, okay, that means now is the above graph. Okay, the above graph, which is the parabola, concave up. So we are talking OE from the x-axis is the distance of OE plus, because it's the whole length, distance of OF. Okay, if we can now know what is F, we will be able to count that distance because we know from OE, we know that OE is 5 units according to this value that is given to us. The only challenge is that OF now. We don't know how much is that F. So, but because we have the equation of F, this point lies on the F function, we can identify the y-intercept of that graph using the equation. If you want the y, you let x equal to 0. This will be 0, 0. Then can you see that your y will be -7? That means this point now happy is 0 and 7. So what is the distance? Is OE 5 units plus the 7 units downwards. That is 7. Okay, that is -7 actually. -7. But now because we are talking the distance, we cannot say if I'm going this direction, I'll be counting 1, 2, 3, 4 steps. When I go down and say -1, 2, 3, 4, 5. No, because it's a distance, we consider it a positive identity, right? So if we go up 5 units, it will be 5 units. We go down 7 units, therefore it will be 5 plus 7, which is giving us how much? The 12 units. That is the distance between the O, the EF. The total distance between EF is that one. So remember we have 0 and 5 there. We have 0 and -7 there. Okay, that is the F graph. That is the G graph. That is an H graph. Right. And then now the next question, they say determine the coordinates of C and D. Remember, C and D are the turning points of the F and G function. What is F function? F function is x squared minus x squared plus 7x minus 7. Can we identify the turning point? Yes, we have 2 ways of doing that, if not 3. The first one, you can use your formula of the turning point, which states x is equal to minus b over 2a. And then we substitute the b value from that, which is 7. It's a negative from the formula, and 7 from the equation. And then 2 into the a value is a -1. So it's -7 over -2, which is 7 over 2. 7 over 2 is the same as 2, 5, right? 7 over 2, 3,5. 3,5. That is 246, and then you are left with the half is 3,5. And then that is the x turning point. And then for which graph? For f, that means this will be for C. Ne? X turning point for C. If you don't go for that formula, grade 12, you can use your derivative from calculus now, because you know that the derivative is stationary, it's a turning point. So now you can derive your f function. Derivative of that function is equal to 2 times minus 1 is minus 2x. Subtract 1, it will be to the power 1. And then derivative of 7x is positive 7. You let it equal to 0, minus 2x plus 7. And then transpose minus 2x, positive 2x, equal to 7. Divide by 2 both sides, therefore x is equal to 7 over 2. Can you see? The same answer, 3,5. All right. And then now to find the y turning point, you must substitute the value of x into your equation. That is the first method. So if you substitute this into your equation, 7 over 2, that will be minus 7 over 2 squared plus 7 into 7 over 2 minus 7. And then into your calculator, this will give you 21 over 4, of which in decimal is 5,25. 5,25. Please write it in decimal so that you know exactly where does that point lie. Because if it is 21 over 4, we are not even sure that it must be between 6 and 7 or between what. But if it is decimal, it says 5,25. You know it's between 5 and 6. That is why we encourage you to write your values in decimal. Right, we now have our turning point as being for C. Our turning point will be 3,5, coordinating with 5,25. Can you see that they are both positive? Let's check with the diagram now. C is there. Yes, they are both positive because the x is positive and y positive at that point. It's very important to verify against your diagram. Are your calculations correct? Okay, done now with the first turning point for C. And then the next one, we are looking for the turning point for D. With D, it's straight and for it's given to you now. Why? Because the equation is given in the form a into x minus p squared minus q. Remember, this is your p, and then that is your q. So if we are identifying a turning point, remember turning point is pq. So that means for the g function now, for the d point, our turning point, remember, if it is negative, it will be positive too. And then this one, it goes with its sign, no problem with the y turning point. It is now 2 and minus 3. That is the coordinates of the D. Can we check D now? D is having x positive, yes. And then the y is negative, yes. This is 100% correct. Okay, that is the expected solutions from you, grade 12. And then the 4.1.3, they say determine the coordinates of P. Determine the coordinates of Q if the coordinates of P are this one. Okay, if you look at P is that point there. And they say that point is 5 over 2 coordinating with 17 over 4. Correct. And they say find the coordinates of Q. If you look at Q now, Q is that point there. Can you see that? They are at the same x value there. If that is the case, that means the Q value there, the x value is also 5 over 2 there. We only need the y value. Okay. How can we get the y value now? You look at that Q point. It lies on which graph? It lies on the concave up. That means on the positive parabola. That is the g function. So we are going to take the g equation. Okay. 2 into x minus 2 squared minus 3, because that Q lies on that graph. For the x value, we substitute the 5 over 2 because we already have that, so that we can get the y value. 5 over 2 minus 2 squared minus 3. Straight into our calculators, grade 12 to the answer, and then this will give us a minus 5 over 2. Therefore, the coordinates of Q will go 5 over 2 coordinating with minus 5 over 2. Okay, That is the analysis of the three graphs that we were having there. And then the next question here, it says that draw the graph of h at x. And then this h at x, the equation is a over x. The minute we see a over x, you must know that it's a hyperbola. If x is on the denominator, we are expecting a hyperbola graph. And then plus q, which is our y asymptote, indicating the intercept and the asymptote. So as you draw this graph, you must indicate the intercept, you must indicate the asymptote. With the following conditions, the equation is not given to us. We are only given the conditions of the graph. Out of those conditions, we must make sense grade 12 now. Number one, they say the a value is less than 0. When you say less than 0, we mean what? The a value is negative. So this value here is negative. So if it is negative, it is now telling you in which quadrant are you going to have your graph now, according to the shape of the graph. If a is negative, remember it goes quadrant 2 and 4, okay? So we are expecting a graph that will be in these two quadrants. That is what this first condition is telling us. Condition number 2, it is saying x must not be equal to 0. That means, what does it tell you? It is telling you that your asymptote for x is at x equal to 0. So you are having that dotted line there. And then it also says y must not be equal to 3. Actually, they are giving you the asymptote, that another asymptote is at y equal to 3. That is why we cannot go to that point. Y must not be equal to 3. Okay? And then now the last one is saying that at h at 2, when x is 2, y is 0. So this simply means we are having a coordinate that is 2 and 0, where x is 2, y is 0. Okay? We take this information now into the graph. Remember, when you sketch a hyperbola, you always start with the asymptote. So we are going to start with our asymptote there. At x equal to 0, that means it's on top of this line, which is our y-axis there. Another asymptote is at y equal to 3, that means at y equal to 3. If an asymptote, it must be a dotted line. And then now we address this 2 and 0 point. Okay, we have 2 and 0, we have a point there at 2 and 0 there. Okay, now we can go to the shape there. It is telling us we must go 2 and 4. That means now the first arm will be in this quadrant, now passing through that one, going this way and so on. And then another arm will be a free arm in that particular quadrant. This is the graph that is expected of us, grade 12. Only using the conditions of that particular graphs. Okay, and then now let's look at the last two graphs. We are having the f at x equal to 4 to the power x minus 4. You must know your graphs. If you look at the equation, you must be able to tell us, oh, this type of a function is an exponential one. How do we know? It's because x is on the exponent. Okay, and then now looking at the g at x one, since there's a square root, that means this one is a circle one. Okay, it's the 1x squared plus y squared is equal to r squared, because x is squared, and with the square root it comes from the square from the y side. That is why we are having a square root. Okay, now we understand we are having a circle with an exponential that we are working with. Now we can attempt the questions. The first one, it says, what type of a graph is f? Oh, we move to f. What type of a graph is that one? X is on the exponent, therefore it's an exponential function. Okay, 1 mark for that. And then number 5.2, write the equation of the asymptote of f. Exponential functions are having only one asymptote there, which is talking to that value of q there. That means we are only having y equal to, not like in hyperbola. Hyperbola is having 2x equal to and the y equal to. But with the exponential, our asymptote will be only y equal to a minus 4 from that negative 4 there. Right. And then now they say calculate the x-intercept of f and the y-intercept of f. Right. Let's calculate the x-intercept now. We know that when you calculate x-intercept, you let y equal to 0 because we are busy with f, right? On the f function, calculate the x-intercept. So we are going to let y equal to 0. And then our equation is 4 to the power x minus 4. Remember, we are solving for x now. We are going to transpose the negative 4 to the side. It will be 4 to the power 1 on the left. And then remember, same base, you equalize exponent. X is equal to 1. That is your first x-intercept for 5.3.1 question. The next question, 5.3.2, the y-intercept, you let x equal to 0. Not working from there, but from the original. You let x equal to 0. You leave y because you are looking for y. F at x is y. G at x is y. R at x is y. Okay, it's representing y of the graph. Then that graph is y equal to 4 to the power x. Now we let x equal to 0 when you look at the y-intercept. And then minus 4. That will be 1 minus 4, which is equal to a minus 3. So our y-intercept will be equal to minus 3. Okay, that is the 5.3. 5.4, it says, sketch the graph of f and g on the same set of axes, indicating all the intercepts with the axis and also asymptotes. Look at the mark allocation grade 12, 7 marks to sketch those two graphs. So sketching is very important to ensure that you can master it. And then let's start now with the exponential one. We know it's an exponential function f, and the asymptote is y equal to minus 4 from our calculation there. Okay, we are going to indicate the asymptote at minus 4, y equal to minus 4. Asymptote is a dotted line. And then with f, we have calculated the x and y intercept. X is equal to 1. At x1, there we are having a point, and y equal to minus 3. At minus 3, there we are having a point. This is an exponential graph. Then it will go closer to that one, starting up there, passing through the y-intercept, the x-intercept, y-intercept. Then we are having our function there. This is the f function for the exponential. And then with the circle, we only relate to the radius. Remember, 16 here stands for r squared. Okay? So now, if it's an r squared, to get r, we must look at the square root of 16, which is 4. So the radius for that circle, if it's a full circle, it will go 4, 4 minus 4 minus 4. But in this case, they say consider only the y that is negative. That means now the graph will only go on the negative y values. It will be a semicircle now. It's not a full circle. A semicircle that is negative on y. Okay, so now the radius, it is 4 in this case. That means now the graph is passing at minus 4, at 4, at 4 there. We are following the equal distance because it's a circle. It's 4 units to the left, to the right, and also downwards because it's a negative 1 on y. So then we'll draw our semicircle, half circle there. So that is the expected graph from you, grade 12. And then now the allocation of mark on the f function will be for the x-intercept, for that point there, for the y-intercept, second for the asymptote, for the shape of the graph is 4 marks. And then for the second one, it will be for the x, both x-intercept, and then for the y-intercept and for the shape. That is why we are having 7 marks on that one. And then 5.5 on your sketch in 5.4, the sketch that we have just drawn, use letter A to indicate where f is equal to g. The graphs are equal at the point of intersection. Can you see that they are intersecting here? We'll just put a letter A there to show that they are intersecting. Then you'll get your extra 1 mark for that one. Okay, and then 5.6, which is the last question, still on the same graphs that we have drawn above. They say write down the equation of h. And then they say h is when you take f and then you shift f how many? 5 units upwards. Okay, they say in order to have an h at x function, take your f at x function and then shift it 5 units upwards. That means it will be plus 5. because you are shifting up. You add 5 to y because f at x is your y. So it's y plus 5 because it's a movement up and down, it's on the y-axis. And then now from here, now let's determine the equation of h at x. What is f at x? F at x is 4 to the power x minus 4. We have now added a 5 in order to have h at x. Then therefore the h at x function is h at x 4 to the power x plus 1. That is the equation of the h at x graph. Okay, lastly, grade 12, 5.7, write down the range of G. Do you still remember G? G is that graph that we have drawn above, which is the semicircle passing minus 4, negative 4, and then with the positive 4 there. And then they say write down the range. When we are ranging, we are taking the y values that lies on the graph. So can you see that the y values of this function, they start there up to here only. That is the only point. You can move from 0 up to 4 with that graph. You can't go beyond 0 there because it ends at the x-axis. You go down, down, down up to minus 4. You can't go below minus 4 because that graph does not continue on the negative 4. That means our range will be between two values, which is 0 and 4. As you test with your ruler there, you can see you touch the graph only from 0 to minus 4. Above 0, there's no graph. And then below minus 4, there is no graph. So our range will range between 0 and minus 4. So now range, we are talking to the y value, it will be between, okay, and equal. Starting with a smaller number, which is minus 4, end up at 0. That is the first notation. If you don't do that one, you can say y will be an element of square bracket minus 4 and 0. That is another notation that you can give us grade 12. And then this is worth 2 marks. Either that notation or that one. Okay, this brings us to the end of today's lesson. And then this lesson was brought to you by the Gauteng Department of Education in collaboration with Cybono Discovery Center. Thank you very much, grade 12. See you next time.